Hello. Today we're going to be talking about factoring and what factoring is used for in calculus. As you know, math is kind of a building subject where you build on the basic skills that you'll build that you learn in algebra. You're going to use those continuously through your calculus classes. So, to start, we'll begin by reviewing what it means to multiply polynomials together. And we'll start with the basic example of a plus b times c plus d. Now, as you learned in your previous classes, the easiest way to multiply polynomials is to FOIL. To FOIL, we have this acronym. The F for FOIL stands for first. So when we begin FOILing, we'll multiply our first two variables in each polynomial, which means we have a times c. Now, our O means we're going to multiply our outer, our first times our outer. So again, we're going to begin with our A again, and we're going to go to our outer on our second polynomial. And we'll add that to our first. Now our I stands for our inner. So we've exhausted our A, and we're going to multiply by our inner two variables. So we'll have B times C. And then the L, as you can imagine, stands for our last. We'll have the b times the last polynomial, or variable in this polynomial. So, pretty basic. I know that you've probably learned this before. It's just a quick, easy review. So now we'll move on to something just a little bit more advanced. Not much. We'll have x plus 2 times x plus 3. Again, we're going to FOIL, so we'll have our first times our outer, so x times 3 is 3x, times our inner, which is going to be 2 times x, and then our last. Now, since we have basically three different groups of numbers, one with our x squared, one's with coefficients in front of the x, and then the one with just a constant 6, we can start to group these numbers. There's no other x squared or a variable with a square to it, so we'll just have x squared. These x's have different coefficients, so we can add them together and just have 5x plus our constant 6. So again, another easy problem. Now we'll move on to something, each one of them, as you can imagine, is going to get a little bit more advanced. Here's a problem that we often see with college students as they're working through their calculus homework. So they think that a plus b quantity squared can be written as a squared plus b squared. But as you should know, that's not right. Let's look at why. If we have an example of 2 plus 3 quantity squared, we know that any numbers that are grouped together by parentheses, using these grouping rules, we can add those numbers together, and we're going to get this written as 5 squared, which we know is 25. So, let's break this down. If we have it written as this and we know it's not correct, we can break apart the square. Anytime you have a number squared, it's just that number written or multiplied by that number again. So we end up with a plus b times a plus b. So again, we're just going to be able to use this as FOILing, or solve this by FOILing. So we'll have our a's multiplied again by each other. Our first, a squared, our outer, a times b, which is just ab, our inner two numbers, which is b times a, and then our last two numbers. So b squared, b times b. Now, as you should also know from earlier math classes, when you're multiplying, it doesn't matter which number comes first when you're solving it. So both a and b times a have the same variables, so that we can group those together and write this whole answer in its simplest form as a squared plus 2ab plus b squared. So this is actually the answer to a plus b squared, and it's not a squared plus b squared, as most students typically, or as some students typically, confuse the two together. So, move on to another example. For our next example, we're going to have, similar to a plus b squared, but we're going to have x plus 2 squared. And again, this is not simply written as x squared plus 4. We know that's not true. We just looked at y. So let's solve it out the other way. We can have x plus 2 quantity times x plus 2. When we FOIL these together, we'll have x times x, so x squared, x times 2, which is 2x, 2 times x, which is another 2x, plus 2 times 2, 4. So our final answer would be x squared plus 4x plus 4. So again, a simple problem. Now we're going to move on to problems whenever we have a quantity raised to exponent n. So if we have a plus b raised to quantity n. Before, we've just been looking at when we have different groups of numbers squared. So what if we have something raised to like the 4th power? How are we going to solve that? We don't want to FOIL it out 4 times. We're going to want to make this a little bit simpler. Luckily, there's a certain trend in math called Pascal's triangle that we can use. It'll help this process be moved ahead a little bit quicker. So whenever we have any group of numbers raised to n power, we start building this triangle called the Pascal's triangle. If the n is 0, our triangle begins with just a 1. So this is for any number with a 0 power. Now, if we raise to n equals 1, start getting to the 1st power. Anytime we start building this triangle, or building this tree, it's going to get a little bit wider, kind of as a pyramid. So for the 2nd power, we're going to have, now the trend is starting to kind of develop. So what you want to do is every time you're going to add an extra number to your line below, and anytime you have a number between two different numbers, so like this 2 between the 2 ones, you're going to add those numbers together to get to 2. So we're at our 2nd power right now. If we want to go to our 3rd power, we're going to have 1. So between these two numbers, we're going to get a 3. Between 2 and 1, we're going to get another 3. And then on the end, we always add 1. So this is for the 3rd power. Now, I asked if we had a plus b to the 4th, how are we going to solve this? Here's our problem. So we can keep going for as many n's as we want. So to get to the 4th power, we're going to have 1. Every n should have a 1. Between these two numbers, we get 4. Between 2 3's, we add those together and get 6. Another 4 here, and then a 1 on the end. This is to our 4th power. So now that we've built our triangle, we know that these 5 numbers here, with any group of numbers raised to the 4th power, we're going to begin with these 5 coefficients. So we have this built. Kind of be ready to get started over again here. Give us some more room. We have our problem. Like I said, we have our 5 exponents. So let's write these out real big where we have plenty of space to work. between each of these numbers, we're getting rid of all of this. Now we're going to start plugging in our variables. Here, to begin with, we're going to have our first variable. In this case, it's going to be an a. And you raise it to the power that the whole quantity is raised to. So in this case, we're going to have 1 a to the 4th. And then we move down the line. Every time we have a different coefficient, we're going to add another a, or we're going to subtract 1 from our exponent. So we have a to the 4th, now we're going to have a to the 5th. On the 6th, we're going to have another a, but it's going to be a to the squared. And then on 4, we'll have just an a. Now, we work backwards for our second variable. So we'll have b to the 4th, b to the 3rd, b squared, and then b. Between each of these groups of numbers, we're going to add them together. So we can break each part down because it's kind of jammed in here to get our final answer. So now that we've seen Pascal's triangle, we're going to move on to multiplying polynomials together. As you remember, our first couple examples were just binomials. So what happens if we have a problem like x cubed plus 2x squared plus 4x plus 1 multiplied by 2x squared plus 2. FOIL is not going to work so well anymore, is it? So the way that you kind of look at these is you just take one term at a time and you're going to multiply by each term in a different quantity. So I'm just going to take my x cubed and multiply it by 2x squared. I'm going to get 2x to the 5th. So remember, anytime you have a variable with exponents that you're multiplying together, you just add the exponents. You're not going to multiply those two together. So x cubed times 2x squared is just 2x to the 5th. Then we have our x cubed again. We're going to multiply it by 2 this time. So we'll have 2x cubed. And then we move on to our second term. We have 2x squared times 2x squared, 4x to the 4th. And then we have 2x squared multiplied by 2 again. It's going to be 4x squared. We move to our third term. 4x times 2x squared is going to be 8x cubed. And then we have 4x times 2 is 8x. Plus 1 times 2x squared is 2x squared. And 1 times 2 is 2. So from here, you can add your like terms and simplify this problem. But for time's sake, we're just going to move on to getting into factoring. So let's get started with that. Our first example we're going to look at is trying to break down x squared plus 4x plus 3. So this looks like an answer to the problems that we were doing earlier, right? But we want to work backwards. We want to turn this polynomial into a problem that looks like what we saw earlier. So we try to look something like this. Now, obviously, we're not using a's and b's, so we kind of want to break it down into terms of x's and numbers that make sense such that when we multiply this, when we FOIL this out, we get the answer to be this. So the way that I always begin these is we know that we're going to have two polynomials multiplied by each other. So I always just break up my different quantities. When you look at your first term, in this case we have x squared. So we know that if we're multiplying our first two numbers together, the only way we're going to get x squared, or the simplest way to get x squared, is to multiply an x times an x. So that's a good starting ground for us. Now if you look, all of these numbers are positive, so we can kind of assume, a lot of this factoring is assuming, making guesses to see what makes sense, and then you can work backwards to check your answer. So since I have two addition signs between every term, I'm going to assume that my next, or that in each polynomial, I'm going to be adding. Now, for these last two terms in each polynomial, or each binomial, we're going to look for numbers such that when you multiply these two numbers together, we're going to get a 3. And that when we add them together, we're going to get a 4. So we kind of factored the 3 out to see what we can multiply to get 3. So since 3 is a prime number, we know that the only thing we can multiply by 3 to get 3 is just 1. Or it's just 7. So when we do this first problem is pretty simple. We know that 3 times 1 equals 3. So if we go ahead and plug these two numbers in, we end up with x plus 3 quantity times x plus 1 quantity. And if we FOIL these back out together, we can check our answer to make sure that we get our original polynomial of x squared plus 4x plus 3. So let's go ahead and FOIL them out. Our first two times each other we talked about was x squared. Our first times our outer is just 1x. Our two inner numbers is going to be 3 times x. And then our last is just 3. So when we combine like terms, we get x squared plus 4x plus 3. So that's not too bad, right? So let's see what we look like whenever we have problems that get a little bit harder. We start adding in subtraction signs, and we don't have our last term as a prime number. So for our next example, we'll have so again, we have this polynomial. Our first term is going to be x squared. So to begin, like I said, I like to break it into two different quantities and then see what I can start adding into these to make sense of this problem. Again, our last number is going to be a 3, so what can we multiply to get a 3? Back to 3 times 1. So we know that our last two numbers are going to be 1 and 3. Again, our first number is x squared. So this is a similar problem, but we have this negative 2 and the negative 3, or negative 2x and the negative 3. So we'll go ahead and add in our x's. When we start to look at this, we can say, okay, negative 3 times a positive 1 will get us a negative 3. So that could work. Or we could have negative 1 times a positive 3, and we're going to get, again, a negative 3. So now we have two different options to see which, or to plug into our two different quantities to see which one will get us the right answer. So let's just try it. Kind of guess and check. We'll have x plus 1 and x minus 3. And when we FOIL this out, we'll have x squared minus 3x plus x minus 3. When we combine like terms, we see that we got the right answer. Now what would have happened if we would have put in a negative 1 and a positive 3 into the two quantities? If we FOIL these out, we would have gotten x squared plus 3x minus x minus 3. We would see that when combining like terms, we would end up with x squared plus 2x minus 3. So we know that x squared plus 2x minus 3 does not equal x squared minus 2x minus 3. So we can tell that this is our correct answer. Now we'll move on to a third example. So the third example is going to be a little bit more difficult. We're going to start adding coefficients in front of the x. We'll have a negative sign. So again, starting from the basics, we'll have two quantities. Now, instead of having simply an x squared, we have 4x squared. So our first two numbers, we can factor this 4x squared to see what we can get for that. We can either have 2x multiplied by 2x to get 4x squared. Or we could have an x times 4x, and we can still get 4x squared. So again, this makes it a little bit more difficult because now we have to deal with not only the 4x squared, seeing what we can multiply to get that, but we have to look at our negative 3 as well. So we have several options this time. I like to start with a simple, just guess and check again. Now we've got our first two numbers. Let's start seeing what we can get again for this negative 3. We have negative 1 times positive 3, or a positive 1 times a negative 3 will still give us a negative 3. So let's see. Let's throw in a guess again, and we'll say that our positive 1 will be our first answer, and then our negative 3. So we'll use these two terms. And when you FOIL this out, we end up with 2x times 2x, so 4x squared, and 2x minus 3 is negative 6x. 1 plus 2 or times 2x is just 2x. And then a 1 times a negative 3 is negative 3. So when you simplify your like terms, see that we get the right answer. And this answer matches up with our first problem. So we know that we did it right. Now, there could have been multiple opportunities for us to have gotten this problem wrong, but after having practiced several of these factoring problems, it's going to start jumping out at you, and you're going to be able to move through each one a little bit quicker and start seeing the different tricks of the combinations and how they fit together before you start writing them down on paper. And it just makes the code process a little bit easier. So definitely, the more practice you have, the quicker you get, the easier life's going to be for you. So we do one more example now to see why exactly we're factoring and what that's useful for in calculus. So we'll have x squared plus 3x plus 2. So this is going to be a pretty simple problem. If we factor this out, we'll see that we have x plus 2 x plus 1. Now, the more that you do this, like I was saying earlier, the easier this problem or this answer is going to jump out at you. But oftentimes, we aren't just told in math classes to factor this. We're going to be told, see what this, when you set that equal to 0, see what you get for x. Well, we can't just set this equal to 0 and solve for our x values because we have two different terms. We have an x squared and we have an x. So they're raised to different powers. So when we factor this out, we can set each term equal to 0. And when we do that, we'll have x plus 2 equal to 0. And then we'll have x equals negative 2. So that could be one potential answer for our x. We could also have x plus 1 equal to 0. And then we'll get x of negative 1. Now, both of these answers could potentially be appropriate x's such that when we plug them back into the original equation, we get a 0 value. So, but you never want to just rely on this first answer. You always want to plug these back into your original equation to make sure that they are indeed correct. So when we plug in negative 2 squared plus 3 negative 2 plus 2, we'll get an answer of 4 minus 6 plus 2, which is just 0. So we know that a negative 2 is correct. And then when we plug negative 1 in, we'll have 1 minus 3 plus 2, and again, we'll get 0. So we know that x could equal both -1, or -2. So these are what we call the roots. Whenever you set it equal to 0, you're finding the roots of the equation. Now, there are obviously going to be times whenever we have a problem and then we can't factor, we can't solve for the roots in this simple format factoring. So they have developed a formula called the quadratic formula. We'll take a quick look at that. So, for our quadratic formula, we have the equation x squared plus 3x minus 3. Now, using the simple factoring rules that we used earlier, it's going to be obvious pretty quick once you start working on it that there's no numbers that you can factor out easily to factor this problem to a simpler equation. So rather than doing it that way, we're going to use the quadratic formula, which is simply x equal to negative b plus or minus the square root of b squared minus 4 times a times c all over 2 times a. And this is going to be difficult to remember, but there are all kinds of little jingles that you can use to remember that. I encourage you to look up different videos to find those jingles. But when we look at this, it's going to be, when we start using this equation, it's going to be a lot easier for us to quickly find the answer that we're looking for. So if we're looking at the quadratic formula, we see a lot of b's, we have some a's and c's. So we kind of need to see what these match up with our original equation. Now if we look at our standard polynomial equation, we have a x squared plus b x plus c. So this equation looks pretty similar with our original equation. Now we just have to match up our coefficients and our standard numbers and see and plug these back into the original quadratic formula. So we'll look at our a, and we see that the number of the coefficient in front of the x squared is simply 1. In front of x, we have a b value of 3. Our coefficient is 3. And then for c, we'll have -3. The reason that it's negative is because in our standard polynomial equation we have a positive, but in our original equation we have a -3. So now that we have these numbers, it's simple, just plug and chug. So for our quadratic formula, it'll now be x equals, for our b, we'll have a -3 plus or minus square root of b squared. So again, we're using our 3 minus 4 times our a value of 1 times our c, which is -3. All over 2 times our a value, which again is 1. And when we start to simplify these numbers, we can move over here and we'll have x equals -3 plus or minus square root of 9 minus 4 times 1 times -3 is just going to be a positive 12. So we'll have 9 plus 12 all over 2. So if we move up to the top, we'll find our final two answers. We'll have an x equals -3 plus the square root of 21 over 2. So we have our plus here, and then our final answer is x equals -3 minus the square root of 21 over 2. Since it's a polynomial, again, we're going to have two final answers. And we can plug these values into your calculator and then plug them back into your original equation to test to make sure that they do, in fact, equal the 0 that we're looking for. And there you have your factor.